There's this guy that I went to college with. His name is Gary Hirsch, and he's an artist, and he makes these dominoes. He paints pictures on them. He calls them joy bots. I thought they were a lot of fun. These are the only dominoes I have. So I want to play dominoes with you, but the dominoes that we're going to play is a molecular dominoes. You know how dominoes work. You try to put them together. You try to make them match. Sometimes they do, and sometimes they don't match. Well, it's a lot like that with molecules as well. Molecules can attract to each other depending on properties of polarity and another type of attraction called hydrogen bonding, and that's what we're going to look at in this exercise. Hydrogen bonding has to do with four elements and how attractive they are to electrons. The four elements are nitrogen, oxygen, and fluorine, which you'll see are the three highest electronegativity elements on the periodic table, meaning that they attract electrons very strongly, and hydrogen. You often find hydrogen bonded to these elements in molecular substances, particularly biological molecules. Well, elements that have a very high electronegativity, they tend to attract electrons away from elements with lower electronegativity, giving them a strong negative charge in a covalent bond, and the hydrogen's a more positive charge in that covalent bond. When hydrogen is bonded to any of these three elements, that polar covalent bond is so polarized that it creates like a little magnet in a molecule that's very attractive to other molecules that have these elements or have hydrogen bonded to these elements. There's an acronym that I use to remember these four elements, HFON, hold phone. So when you're thinking about hydrogen bonding, hold the phone. Think of hydrogen, fluorine, oxygen, and nitrogen. Hold the phone. Here's how it works. So how does hydrogen bonding work? Well, what we look for in the structure of a molecule are the elements oxygen, nitrogen, or fluorine, and we also look for hydrogen if they're bonded to those three elements. We look for hold the phone, HFON. When we find those elements, we put the charges on them. For example, when carbon is bonded to oxygen in this way, since oxygen has the second highest electronegativity on the table, it's going to attract electrons more towards its side of the bond. There'll be more of a negative charge on the oxygen side and less of a negative charge on the carbon side. We're going to ignore carbon in this process. Also, oxygen has these paired electrons that aren't bonded to anything. That gives oxygen a very strong negative charge on this side of the bond. It's the same thing with this oxygen here. Whatever it's bonded to, it doesn't matter. It's going to have a higher electronegativity than any other element other than fluorine. So it's going to have a very strong negative charge where you find it in a molecule. Oxygen here, since it has a higher electronegativity than hydrogen, will pull the electrons away from hydrogen. Also, it has those pairs of unbonded electrons, very strong negative charge, and the hydrogen will have more of a positive charge. Now, it's true that carbon here would have a positive charge compared to oxygen in these polar covalent bonds, but the positive charge isn't high enough to be considered part of this hydrogen bonding attraction process that we're looking at. So we'll ignore anything that's got a positive charge except for hydrogen. Nitrogen, third highest electronegativity, pulls electrons away from hydrogen, giving that a more positive charge, the nitrogen a more negative charge, also a pair of unbonded electrons, so strong negative charge. Nitrogen will always have that strong negative charge when you find it somewhere in a molecule. Fluorine, the highest electronegativity element, whatever it's bonded to, is going to pull electrons away, and it has three pairs of unbonded electrons, very strong negative charge wherever you find it in a compound. Oxygen here with three unbonded pairs of electrons, very strong negative charge. Whoever it's bonded to, it's pulling electrons away from. So, wherever we find these opposite charges on different molecules, like this positive charge and this negative charge, those can attract to each other by an attractive force we call hydrogen bonding. Or this negative charge could attract to this positive charge. As long as they're on different molecules, we can have that hydrogen bond attraction. Sometimes even within extremely large molecules, which are made of smaller molecules we call polymers, you can even have attractions within a molecule by hydrogen bonds. We'll look at that more when we build models like DNA. So the way that we represent a hydrogen bond is generally using dots, because we don't want to show that the atoms are connected. We just want to show that they're attracting each other like magnets. These could make an attraction here. There could be an attraction right here. Wherever you have the possibility of opposite charge attraction, we would draw these dots to represent hydrogen bond attraction. Okay, so in this activity, we have some molecules on cards that we can cut out, and what is shown on the molecules are the atoms and their bonds, and we can look for those elements that form hydrogen bond attraction: oxygen, nitrogen, fluorine, and hydrogen. The first thing I'm going to do is I'm going to go through these, and I'm going to put the charges on the molecules where they would go. Okay, so here's an example. This is guanine. Guanine is one of the nucleotide base pairs in the DNA molecule, which is found in all of your cells. And I'm looking for the four elements: hydrogen, fluorine, oxygen, and nitrogen. Here's an oxygen, and since it has a higher electronegativity than carbon and these unbonded pairs of electrons, oxygen is going to have a negative charge. Same thing here with this nitrogen. It's going to have a very strong negative charge. Here's nitrogen bonded to hydrogen. So the nitrogen will have a strong negative charge and the hydrogen a strong positive charge. Same thing is happening right here. This nitrogen has a strong negative charge. This nitrogen, negative charge. Hydrogen's positive charges. Now I'm not going to do this with any of the other elements. I'm not going to do this with the carbons, like this right here, this carbon and this hydrogen. They do not participate in hydrogen bonding attraction because even though carbon has a higher electronegativity than hydrogen and would have a slightly negative charge compared to hydrogen in this polar covalent bond, it's not a strong enough polarity in that bond to attract other molecules the same way as you would have if you had oxygen, fluorine, nitrogen. Those three. Hold the phone. Here's another molecule here. This is isopropanol, or isopropyl alcohol, the one that you find in the medicine cabinet for cleaning cuts and wounds and things. So I'm looking for oxygen. There's an oxygen, and so it's going to have a negative charge wherever it's found in that bond. With the hydrogen, we're having a more positive charge. None of the other atoms are going to have charges that we're going to consider for hydrogen bond attraction. Only when you have oxygen, fluorine, and nitrogen. Some of the cards in the packet have more than one molecule drawn on it. You know, just like a domino has two sides with different numbers on it, we can have several different things going on with our dominoes game. So I'm going to label the negative charges on the oxygens and the positive charges on the hydrogens throughout the entire set here. And then I'll do another card. Here's cytosine. Cytosine is another base pair nucleotide in DNA. And so I'm looking for hydrogen bonded to nitrogen, fluorine, oxygen. Here's oxygen, not bonded to hydrogen, but still with a negative charge. Nitrogen with its negative charge bonded to hydrogen with its more positive charge. This hydrogen I'm not going to consider because it's bonded to carbon. This nitrogen, it's one of the three I'm looking for: fluorine, oxygen, nitrogen. Nitrogen and hydrogen here. The nitrogen with its strong negative charge, the hydrogens with their positive charges. Okay, now that I've got my dominoes all labeled, just like dominoes have numbers on the sides that match up, now I've got the charges labeled on my molecular dominoes, and I'm going to try to match them up. And when I match them up, I'm going to tape them together. Actually, tape works by hydrogen bonding too. The sticky part comes from an opposite charge attraction between the molecules in the tape and molecules in whatever you're sticking to. It's kind of interesting the way that works. So let's clear this aside. I'm going to take one here. I'm going to start with my hydrogen peroxide. There's 4 molecules on here. And I'm going to take my cytosine here, and any one of the positive charges on here can attract to any one of the negative charges on here. So let me just take these and I'll start with those. This positively charged hydrogen and that negatively charged oxygen, those can attract. So I'm going to draw my little hydrogen bond attraction, those little dots right there, to show where they're attracting to each other. I'm going to take a piece of tape and then I'm going to hydrogen bond them together. So there's my first 2 dominoes. And I'll continue doing that process, linking together as many dominoes as I can. Some molecules like isopropanol, when you bond them, there's no other side that it can bond to. So just like playing dominoes, sometimes you end the row. That would happen here if I did this with my isopropanol. So let's see here. Where could I put the isopropanol? If I try to put it over here, these are positive charges and they attract, so I can't put it there. How about down here? Nope. Here we go. I could get this negative charge and that positive charge to attract. I know it looks like I'm putting it on top, but you know, think about these. These are molecules, and if they were swimming around in a solution, they're not flat. They can move around anywhere. Let's try this one right here. Let's take my guanine and see where I can put that one. I see a negative charge here and a positive charge there, so I could put those two together, and that would be my hydrogen bond attraction. Here I can either draw the dots, or I'm just going to put a box around that one to show where they attract to each other, and I can tape them together with my hydrogen bonding tape. And I'll keep doing this until I've used up as many of the cards as I can. Let's see, where could I get a negative charge to attract to this positive charge? Not over here. Well, let's see. I see right here. I could do that on my guanine. So I'm going to draw my dots between the positive charge of my isopropanol and the negative charge here on my guanine. I'll get my hydrogen bond tape here and I'll stick them together. And I'll continue to do this until I've used up all of my pieces. And you can do that too. See how many you can link together.